This is a short video to talk about some of the challenges that we see customers facing with SD-WAN. A pattern that we've also seen is that a lot of SD-WAN projects get started but never finished, or they're half finished, and it's not always because of the fact that the customer is not able to do it. Sometimes it's to do with resourcing, somebody moves on, people just get stuck and there's no funding to get help or something like that. But by following some of these tips and tricks that I'll show you over the next few minutes on how to plan for your SD-WAN deployment, you'll hopefully be in a better place before you get anywhere near deployment. So the purpose of this video is really emphasizing the importance of planning and having a proper high-level design, low-level design, and real intention before you go into your SD-WAN project. So what I'm going to cover in this video is consideration and why you should consider transport types. You should also think about redundancy requirements at the hub and the spoke end, because this can impact your traffic flows and your failover mechanisms, which can then impact your operations once the project is actually fully deployed. Central management architecture. Different manufacturers have different mechanisms and tools to do this. Some of them are cloud-based, some of them are on-prem, some of them are hybrid or either or, and you need to make the best decision for your organization. Application usage and the required traffic flows in your network. This doesn't change just because it's SD-WAN. My opinion is that the first questions that your partner should be asking you is, what applications do you have? And what are the traffic flows? Where do you need to get to? And if they don't know how to extract that information correctly, then yeah, let's just say that they should. Operational complexity. This is about over-engineering the network, potentially. So with that short intro in mind, bear in mind this is just a basic introduction to a basic SD-WAN network. It will not cover global scale or anything like that. It's just going to talk about the concepts. So first of all, if we start talking about the transport types, and I just put a couple of different WAN transports in here, and we'll just call it transport 1, transport 2, and then if we have, I'll just start off with a single SD-WAN router here. We'll call it R1. And then we'll have another router here. We'll call that R2. And let's say that these are connected with a back end. These are two data centers. So these are your SD-WAN hubs. Which are connected via a data center interconnect. Let me just fix that line. Okay, so we've got two SD-WAN hubs, DC1 and data center 2. Now, once we start connecting the hubs into the different transports, so if both hubs are connected into transport 1, so say that's MPLS, layer 3 VPN, then it's quite easy when we start putting sites which are connected, for transport 1 to then build SD-WAN overlays and underlays. SD-WAN overlays via this underlay. So transport 1 and transport 2 are underlays. Now, if this is the internet, and this, let's just say, this SD-WAN router has connectivity to the internet, and this remote SD-WAN router has connectivity to the internet. You can see I've got one site and two hubs here. Now, there's a problem in this scenario. I'm not going to ponder on it, but it shows you already. If we are to just remind ourselves that this is all meant to look logically like one network. So one SD-WAN overlay. This is the overlay that I've put on top, and effectively this has a line here. This has a line here, and this has a line going here. This looks like it's becoming a valid design, right? But actually we've got a problem here, that we've got a single point of failure. If this router 2, if this circuit to MPLS network goes down, and then this circuit to the internet goes down, we have no redundancy via our second hub. So you need to plan for these types of things. What would fix that, if I put these back in, is simply having a circuit here, but this is where you see that costs can go up if you have like lots of different transports. So that covers kind of like the first 2 points, where you have to consider the types of transport that you use, and it can really have an impact on redundancy, routing patterns, and routing considerations, which I'll cover in a different video later on. The third point is in relation to central management. So this is really just to highlight that different vendors have different management platforms. So you might have like a management platform here that controls, I'll just join this to this line, to the data center LAN, and that may be a single instance, it might be a high availability pair in that data center, or it might be an active and a standby in the other data center. But that's effectively your on-prem solution. Might be a VM, could be a physical appliance. All these things are going to have a different impact on your costs and your operation, your installation, lead times for delivery. All these types of things are often just overlooked unless you think about the best option for your organization. The other thing that some of the SD-WAN vendors have for management is they have cloud-based. So they have normally on the internet. So they have orchestrators located on the internet, and I know I said that we were only talking about, for example, an SD-WAN that's in one particular country. You might work on an SD-WAN that's in 2 different continents. So you need to make sure that the orchestrator has adequate reachability, or the SD-WAN controller has adequate reachability from a latency perspective and all these types of things to your site. So for example, if you only had one management orchestrator hosted in, I don't know, AWS Frankfurt, and you had sites in Latin America, Brazil, all these types of countries, and also maybe in Asia Pac, then the latency you might have to pay for a circuit that's adequate to meet the latency requirements for the control plane communication to be good. Application usage, I'm not going to demonstrate anything on that here, but in regards to how to do that, but I think I've demonstrated in some previous videos how MNB do RFIs, so request for informations, and we gather application traffic flows the best that we can in every design that we do. So when I talk about the traffic flows, most people say, well, we don't know what the traffic flows are. However, you know if things go to the public cloud, you know if things go to the data center 1, if things need to go to data center 2. These are the traffic flows, and the reason that it's so important in SD-WAN is so that you can plan for your SD-WAN routing policy. Finally, operational complexity. It fits in, I should say, to all these things that I've already talked about. Plus, if you want to start getting into really complex SD-WAN routing policies like SLA, SLA monitoring. So, for example, if link 1 is responding to an application HTTPS GET request within 150 milliseconds, then use that link. But if it goes above 150 milliseconds for an extended period of time or after a certain amount of tries, then use that link here. Then the more of that you do, it's great because you can guarantee or close to guarantee like your applications are going to perform well, but you also need to manage that. And I think sometimes it sounds great, but a lot of the SD-WAN deployments that we see, it's normally because there's of the nature of how SD-WAN works, it's literally instantaneous failover between link 1 and link 2. So what we see more of is customers deploying 2 circuits, a really good circuit and then maybe a not so good circuit that they might put some traffic over, and then they fail over to that one instantaneously. Sometimes it's just exactly the same, so 100 meg leased line and 100 meg leased line, and they would just want reliable connectivity and failover, so as soon as there's a problem, it fails over. So these are some of the things just to highlight the complexity of SD-WAN. You need to go into these things in a lot more details than I have in this video when you're planning your own network, and this is where MNB Networks help a lot of customers. We'd be happy to help anyone who's currently working through a network transformation as well. And we've got a lot of experience working at a local, national and a global scale on these types of projects. So with that, thanks for your patience and for watching the video, and enjoy the rest of your day.